All right, today we're going to tackle a word that is quietly shaping the future of medicine and public health, even if you've never heard of it. That word is biometry. So, what is it and why is it so absolutely essential? So, let's start with a little bit of a puzzle. What do these three things have in common? You've got a high-stakes clinical trial for a new cancer drug, the massive, years-long project to map our entire DNA, and the urgent, minute-by-minute effort to track a global pandemic. I mean, they seem totally unrelated, right? But believe it or not, they all hinge on the exact same scientific discipline. And that connection? It's biometry. At its very core, biometry is the science of biological measurement. You can think of it as the hidden engine driving modern medicine, the thing that takes the overwhelming complexities of life and translates them into data we can actually understand and use. So what does that actually mean? Well, the formal definition is the application of statistical and mathematical methods to biological data. Okay, that sounds a little textbooky, right? But don't get hung up on the jargon. The main idea is actually really simple. It's all about using the power and precision of math to make sense of the messy, complicated, and beautiful world of biology. To put it even more simply, if you want to understand biology, you first have to be able to measure it. And biometry is the science of how. How do we accurately measure someone's blood pressure? How do we quantify if a tumor is shrinking? How in the world do you even count viruses in a tiny sample? It is all about creating reliable, repeatable methods for gathering that crucial data. Now, you might be thinking, hang on, I've heard a similar term, biostatistics. Are those just two words for the same thing? Well, not exactly, and the difference between them is actually a really big deal. Let's think about it like cooking in a kitchen. This analogy really clears it up. Biometry is like your super precise measuring cups and scales. It's what you use to gather the raw ingredients, the data, and make sure you have the exact right amounts. Biostatistics, on the other hand, is the chef. The chef takes all those perfectly measured ingredients and analyzes them, combines them, and creates the final dish, which is the conclusion. So biometry gives us the what, and biostatistics tells us the so what. And you can see why that relationship is just so important, right? You could be the greatest chef in the entire world, but if your measuring cups are wrong, your recipe is doomed from the start. It's the exact same idea here. The most brilliant statistical analysis is completely worthless if the initial measurements, the biometry, are flawed. It's that classic principle you always hear about, garbage in, garbage out. So why all this fuss about getting the measurements just right? Well, because when we're talking about public health, these aren't just abstract figures on a spreadsheet. They are the absolute bedrock for decisions that can be life or death. This quote just nails it. We can't hope a vaccine works. We have to measure its effect with incredible precision. We can't guess if a new drug is safe. We have to measure its outcomes. This is the very foundation of what we call evidence-based medicine. Accurate biometry makes sure that the huge decisions that affect millions of lives are based on solid, undeniable facts, not just guesswork. Let me just throw a number at you. 95%. In a clinical trial, that's usually the confidence level that researchers are aiming for. That means they need to be 95% sure that the effect they're seeing from a drug is real and not just some random fluke. So how do you get that kind of certainty? You get it through thousands upon thousands of rigorous, standardized, repeatable measurements. And that is the work of biometry. Okay, so where does the science actually pop up in our lives? Let's take a look at where biomimicry is quietly at work, shaping our world every single day. Honestly, once you start looking, you see it everywhere. When epidemiologists are tracking the spread of a disease, they're using biometry to measure infection rates. When a pharmaceutical company tests a new treatment, biometry is there to meticulously measure every patient outcome. When scientists are unlocking the secrets of our DNA or trying to figure out the risks of toxins in our environment, yep, that's all biometry in action. You know, you see a chart like this all the time, right? It looks so simple, the new drug is clearly working better than the placebo. But behind these two little bars are just thousands and thousands of careful biometric measurements. Every single blood test, every symptom score, every patient survey, all collected systematically from a huge group of people. This one simple image, which is powerful enough to change medical practice around the globe, is built entirely on a foundation of biometry. So if there's one thing to take away from all of this, it's this. The living world is incredibly, wonderfully complex. Biometry is that amazing bridge. It's the discipline that lets us carefully and accurately translate that messy, beautiful complexity into reliable numbers. And it's with those numbers that we can draw conclusions, make discoveries, and ultimately build a healthier world for everyone. And the crazy thing is, we're just getting started. I mean, from the smartwatch on your wrist tracking your heart rate to incredible technology that can sequence an entire genome in a few hours, our ability to measure biology is just exploding. It leaves us with this really thrilling question. What health challenges that seem impossible today will we solve tomorrow with the next generation of biometry? I really hope this helped make sense of what biometrics is all about. If it did, you know what to do. Give us a like and definitely subscribe so you don't miss the next explainer. And hey, if you're more of a listener, we've got you covered. The audio version is up on all the usual podcast spots. The link for that is waiting for you in the description below. And last but not least, we really do want to hear from you. What's that one big topic you want us to break down next? Drop it in the comments below. We read every single one. Thanks so much for watching, and I'll see you in the next explainer.